Dear student, let us continue with the Module 2. In this lecture video, we will be studying the role of lexical analyzer. Here, the role of lexical analyzer is to take the source program as input and it generates the token and it provides to syntax analyzer or which is called parser. And some lexical analyzer will also store some data or some data value to the symbol table. This parser, it will take the token and it will use the symbol table entry values to generate the semantic analysis. It will generate the semantic analysis, and parser will also provide the next get next token acknowledgement to the lexical analyzer. Let us see. The main task of lexical analyzer is to read the input characters of the source program and produce a sequence of tokens as output, which we saw. It is what it is doing. It is taking the source program as input and it will generate the sequence of tokens. Now, the secondary task of lexical analyzer is to stripping out from source program the comments and white spaces like tab, space, new line, character. It removes the comment lines, white space, tab like tab, space, new line characters from the source program, and it also correlates the error message generated by the compiler with the source program. In the source program, if any error is there, it will correlate that error with the error message and it will display the error message to the programmer. Next one, lexical analysis versus parsing. There are several reasons for separating the analysis phase of compiling into lexical analysis and parsing. See, lexical analysis is different part and parsing or syntax analysis is different part. There are several reasons why these two things are separated. So, because of this design of the compiler, it will become more simpler. This is one reason. Another reason, compiler efficiency is improved. The efficiency of the compiler is improved by separating the lexical analyzer and parsing analyzer. Next one is compiler portability is enhanced. It is also third advantage is that the compiler portability is enhanced because of separating the lexical analysis from the syntax analysis. So next one, let us see about tokens, patterns, and lexemes. So token is what? It is a sequence of characters that can be treated as a single logical unit. For example, if, else, these keywords are if. So if it is a single unit, single set of characters, which will be considered as a single unit, logical unit in the program. So that will be considered as a token. So token is a pair consisting of token name and an optional attribute value. Token name is an abstract symbol representing a kind of lexical unit. So token, it has the token name and it should also have an attribute value. The different types of tokens are identifiers, keywords, operators, symbolic symbols, constants, etc. Next one is pattern. So pattern, it is a description of the form uh, that the lexeme of a token may take. It is the rule, it is the description of the form that token can take. For example, if keyword as a token, the pattern is just the sequence of characters that form the keyword. So suppose if it is a token, then what is pattern? Pattern is first if should come, then F should come. So this is the sequence. First if, then F. This is the sequence. This is the pattern. Then lexeme. Lexeme, it is a sequence of characters in the source program that matches the pattern for a token. So it is a sequence of characters in the source program that matches the pattern for token. So suppose we have a token called if. Then what is this? What is its sequence? So first I, then if. Okay. So I if it is a sequence of character and it is also matching with the token. So I if it is a lexeme. Lexeme. For example, pattern for the reload consists of 6 lexemes. So, what is the pattern for reload? I mean, assignment or comparison operator equal to, less than, equal to, greater than, equal to, less than, greater than, or less than, greater. So these are the lexemes. For example, let us see token we have y. What is its lexeme? It is a y. And patterns are the sequence of character which forms this lexeme or token. So WHILE. Next token, suppose it is if, then its lexeme is if. Then what is the pattern? IF. Next token, suppose it is ID, and lexeme it is Y. Okay. Then what is the pattern? Letter followed by letters or digit. So letters followed by letters or digit. So this is the pattern. This after that it should follow some digit, number or letter. Then number. Lexeme is 25. Number is total. And any numeric constant, that is the pattern. Literal, temple. Anything surrounded by double quote is pattern. Then lexical error. First, it is hard for lexical analyzer to tell without the add of other components that there is a source code error. There is a source code error. So it is very difficult for lexical analyzer without any further information that it has a source code error. Because suppose if we have a line called fi a equal to f of x, but here fi it can be considered as an identifier also, because identifier can be any name except the keyword. But if if it will be considered as a token as if keyword token. So the simplest how to recover from these lexical errors. So the simplest error recovery strategy is panic mode recovery. We delete successive characters from the remaining input until the lexical analyzer can find a well-formed token. So we can delete one by one letters, and we should check whether lexical analyzer has formed a well-known token or not. So other possible error recovery actions are: delete one character from the remaining input. So from the remaining input, we should delete one character. Insert a missing character into the remaining input. We can insert a missing character into the remaining input. Replace the character by another character. We can replace one character by another character, or transform